All right, here are our solutions for quiz 3 for Math 211. A couple of different sections covered here. First one on these different numeration systems. So the Babylonian system and the Mayan system are the two that I'm going to test here. And basically what I'm asking you to do is write the number 5,000 using those systems. So maybe first over here in the Babylonian, we first want to consider our positioning. And I might need a calculator for this. So let me pull one out. So we want to kind of use up 5,000. Well, 216,000 is way too big, so we won't want anything in this position here. But 3,600 will help. And in fact, exactly one 3,600 will help. So what I want is 1, which is this little triangle thing, in that position. And that uses up 3,600 of the 5,000. So you might be able to figure out in your head that that's 1,400. Or you could punch it into a calculator over here and keep track of everything as we go. So I got 1,400 more. I can't get any more 3,600s, but I could certainly get a whole lot of 60s. So maybe I'll divide that by 60 so I can figure out how many 60s I want. Well, it looks like I can get 23 60s out of that, and then I'll have a little bit left over. So how am I going to get 23 60s? Well, this little symbol gives me 10. So there's 10, and there's 20, 21, 22, 23. And I guess just for consistency's sake, I'll fill these in. So now I used up the 3,600 and 23 more of these 60s. Well, 23 times 60 is 1,380. And maybe you'll remember that I needed 1,400 more. So if I do 1,400 minus 1,380, I'll get the 20 that I have left over to write. Since 20 is less than 60, I don't want to put them in this position. I'll have to move over to the ones position. And so to put them in the ones position, I need 20. Well, that's 2 10s. So I can come over here and just write 2 of these 10s. And then that would work as the number. So this mess right here would be my answer. I guess I can just leave it as is. And then we kind of repeat the process. We go over here into the Mayan system. I still want to write 5,000. So that's none of these 7,200s, but it's a whole lot of 360s. How many 360s? Well, let's take 5,000 and divide it by 360. If you do that, you get 13 and change. So I want 13 in this third row here. No, yeah, this one, this third row. So how do you write 13? Well, these bars give you 5, and then the dots are 3s. So I can kind of write it as 2 bars and 3 dots. And that uses up some of what I need. That uses up 13 of these 360s. How much is that? Well, 13 times 360 is 4,680. And I started out with 5,000. So if I do 5,000 minus 4,680, I'll get 320, which is how many more I need. And then I'll come over here and be like, well, that's no more 360s. 320 I can get out of 20s. And you might be able to figure out how many 20s it'll take to get 320, or you can just kind of go easy style here and do 320 divided by 20 and get 16. So I want 16 in this 20s row. Well, the way I write 16 is 1, 5, 10, 15, 16. So this is the 360 row. This is the 20 row. And so what I just did is used up everything I have. So I don't have anything else. So I'm done. No, for the Mayan system, they had this concept of 0. And I want to make sure the reader knows that I have 0 in this bottom column. So I have to draw that weird looking thing. Which kind of looks like this, and then like this, and then like this, I think. Yeah, good enough. So this would end up being my answer. Maybe to kind of detail my work a little bit here, I can even say that this right here represented 1 times 3,600, which equals 3,600. And then this right here represents 23 times 60, which I don't remember what that was equal to. I'll plug it in real quick to figure out it was 1,380. And then this right here represented 21s, which is just 20. And if you sum these guys up, you get the 5,000. So you don't need to show this. This is just me trying to show my work for your benefit maybe. Same idea over here. This is the 360 row. And how many of them do I have here? Well, 5, 10, 13. So 13 times 360, which I will pull out a calculator to do. So I don't remember what that was equal to. It was 4,680. And then this is 16 times 20, which was 320. And then this was 0 of these ones, which is just 0. And if you go adding things this way, you'll get your 5,000. Awesome. So the answers are just the things in red. Maybe to make that clear, I'll put a little box around those. But now I've kind of shown my work a little bit too. All right, moving on. There's another question here. We're dealing with sets. And so what I'm given is this shaded region here and asked to express it as a union, intersection, complement, difference, whatever I want, of the sets A, B, and C. So a lot of different ways you can do this. For me, it's easiest to notice that just by taking A, I almost get all of this stuff. All I got to do is add in this little segment here. And this wedge is B intersects C. So if I take A and I find the union of A and B intersects C, I think I'll get everything that I need. Be a little bit careful with parentheses. If you just write A union B intersects C, I won't know if you mean A union B and then intersect that with C. So these parentheses are kind of important. Similar logic here. I can start out with A, but then I just have to get rid of that tiny little bit. So A, take away. And then you have some options on what you take away. You could take away A intersect B intersects C to get this tiny little part. Or you could take away B intersects C, which means take away this entire wedge from A, leaving this stuff here. So either of those will work as answers. It's a little bit hard to show your work when you're dealing with sets. I think I'm going to tell you to try your best to show your work, but I'm not sure how you're going to do that, and I'm not going to at all. I'm just going to call those my answers. I might write, though, other answers possible, so that when you check these out after the quiz, you don't freak out because your answer looks different. I thought mine was right. Maybe it is. All right, and then down here, use the provided Venn diagrams to shade in the specified sets. Okay, I went a little bit overboard here. But what I want you to do is start out with the union of A, B, and C. So all of this stuff. And then from that, take away A intersect B intersect C. So take away this little part right here. So if you're following along, what I have is all of this with a little hole in the middle. But then I want the complement of that. To figure out the complement of that, I want to shade in everything that wasn't shaded in before. So that little hole in the middle will get shaded in, as will all of the stuff out here on the outside. Probably don't want to sit and watch me shade this in, so I'll try to do this a little quicker. Maybe I'll go back and fix it after the fact. What you end up with is something like this. And this is one of those cases where I think it's a little bit easier to check your answer when you're dealing with complements like this. Think about if this bar wasn't here. A union B union C minus A intersect B intersect C. Think if you were just doing that. Would you shade in all the white stuff and none of the blue stuff? If so, then my answer here will be correct because you're kind of switching everything when you take the complement of all that. All right, over here, in this one, I'm starting out with the complement of A union B. So I'm starting out with everything that is not in this region right here. And then from that, I am taking away everything that is not in C. So I'm starting with everything that's not in here. So I got the outside and this little wedge right here. And then from that, I'm going to take away anything that is not in C. Well, it's going to take away the outside, and it's just going to leave me with this little wedge right here. So the answer to this problem would just be this little wedge right here. And that, I believe, ends up the quiz, so I will call this good and end the video here.